Okay, I'm on. Here we go. 5/20/19. Wow. Okay, so if I check it out, number one, dang it, it's not a right triangle. So there's no hypotenuse. Okay, first of all, everybody listen. There is no hypotenuse. So first of all, there's no hypotenuse. There's no Pythagorean theorem. Pythagorean theorem does not work. So I don't know where you want to write, but just no Pythagorean theorem. Pythagorean theorem only works on right triangles. Period. Okay. We're going to do everything in degree mode because we've got degrees. See the 40 degrees. So we're going to do ours in degree mode because everything's going to be given to us in degrees. Now, if I take a look at number one, and if I look at the angle, what happens is this. This is not a hypotenuse. This is not a hypotenuse. And this is not a hypotenuse. So what we have is, really, we have two adjacent sides and an opposite side. Adjacent means next to. So it changes around. So what happens is this. If I have a pair of opposites, so I'm going to show you the law of sines, but you need to have a pair of opposites, an angle and its opposite side. You have to have a pair of opposites. So you must have an angle and its opposite side. It's a super easy formula, okay?
But if you don't have the opposite?
Then we're going to learn the law of cosines. We're learning that on Wednesday. Good question.
What do you think ambiguous?
I can ambiguous case. We're going to talk about that tomorrow. That's when we'll learn about the angle side triangle. Yep. Okay, so here's what I want you to look at. So the law of sines looks like this. It is going to be, you ready? Opposite 1 over sine theta 1. Write that down. So here I have an angle and its opposite. I'll give you a moment to write that down, okay? Formula's really easy, okay? So here I have an angle and I have its opposite side. So let's call that theta 1 and opposite 1. You okay with that? So if that's the case, then I can set up the sine. I can set up 5 over the sine of 40 equals, okay? Then it equals opposite 2 over sine of theta 2, all right? So if I look at my triangle, it goes, that's the formula. Or you could write the exact same formula, but just inverted. You could rewrite it as sine of theta 1 over opposite 1 equals sine of theta 2 over opposite 2, okay? That is the law of sines. It's even easier than right triangle trig, isn't it? How does it work? Okay, so here's my side, my 6. So this angle here has to be theta 2 because it's its opposite. Does that make sense? So I've got opposite. I've got 5 over the sine of 40 equals 6 over the sine of 2. But I'm going to change this around a little bit, okay? So what I like to do, and I'm going to scratch this out for a second. Okay? What I like to do is put what I don't know down first. What don't I know? So let's use this version of it. Let's use this version of it because that's what I want to find. So I'm going to rewrite it as sine of 40 over 5. So I'll put what I don't know down first. It's going to equal sine of theta 2 over 6. So now I'm just going to cross multiply. So I'll bring the 6 up here. And I'll rewrite this as 6 times the sine of 40 over 5 equals sine of theta 2, okay? Okay, I can do that. So then I can do this in my calculator. I can go, okay, what is 6 times the sine of 40 divided by 5, and I get a decimal. But I want to find the angle, right? So what button do I push when I want to find the angle?
Inverse.
Yeah. So I'm going to go sine inverse of this 0.7713 blah 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 blah, but I'll just go sine inverse of the answer for accuracy, right? You guys all know about the answer button, right? And I get an answer of about 50.5 degrees. That's it. Boom. Right? That's it. Right. So let's look at number 2. Okay, number 2. Let's see, I've got these two angles. I need a pair of opposites, so we could probably find this angle here, couldn't we? Let's call that theta 1. So how am I going to find theta 1?
By equaling it to 180 degrees.
There we go, theta 1. So let's just go 180 minus parentheses 82 plus 70. And let's see what that's going to be. 180 minus parentheses 82 plus 70. And I get an answer of about 28 degrees. Okay, so let me put that in there. I know that angle's 28 degrees, so I'm just going to put 28 degrees in there, okay? Now, it's all about opposites. This is even easier than this. Olivia, trust me. Super easy, okay? Do you see a pair of opposites? Yes. The opposites. You have a pair of opposites. You have an angle and its opposite side, right? You guys agree with that? So I'm just going to circle that. There's my opposites, okay? You don't have to circle it, but I like to get a visual, okay? You have a pair of opposites. Now, you could either find this opposite side or this opposite side. It does not matter. Okay? Which one do you want to find? It doesn't matter. Do you want to find, let's call this one X, and we'll call this Y. It doesn't really matter which you call, okay? What do you want to find, Jace? X or Y?
X.
X it is. So that means that this is theta 2, and that's my opposite 2, right? So I'm going to write down X over the sine of 70 equals 13 over the sine of 28. Okay, so write down what you don't know first. Write it down. I don't know X, but X is the opposite. It's the opposite to this angle, right? Okay. So I'm going side over angle, so I got to go side over angle. So what I'm doing this time is I'm using the first formula, right? It's the exact same formula. It's the exact same formula, but it just depends on, you want to find the sides, write the sides down on top. It's just easier to cross multiply. Does that make sense? Okay, so then to solve this, let's multiply the sine of 70 up here. Okay, to solve this, so I'm going to go, okay, X is equal to 13 sine of 70 over sine of 28. I'm just going to use my calculator, okay? Clear, I'm going to go 13 sine 70 divided by sine of 28, and I get an answer of 26 even, okay? 26 even. Now, let's do one more thing. Let me put my 26 in, because this is where it's really important that you realize there is no Pythagorean's theorem, okay? So this is 26, okay? Now, you cannot go a squared plus b squared equals c squared. You can't. Because the question is, well, which one's c squared? There's no hypotenuse, right? So we're going to do the law of sines again. That's easy. Okay, this time let's find y. Different color. Let's use green, okay? So to find y, its opposite angle is the 82. You guys agree? So, what's that? Yeah, sorry. Yeah, there you go. Okay, so well, let's find y. Its opposite angle is the 82. So it's all about opposites. So write down what you don't know first. So I'm going to write down simply y over the sine of 82. So it's side over sine of its opposite angle equals side over the sine of its opposite angle equals my 13 over my sine of 28. And again, I'll cross multiply and bring that up there, right? And I'll have then y is equal to 13 times the sine of 82 divided by the sine of 28. Sorry, it's so squished in there. And I'm just going to use my calculator to get it. So we'll go 13 times the sine of 82 divided by sine of 28. Boom. And the answer is about 27.4. Easy, isn't it?
Yeah.
It's easier than hypotenuse and adjacent, but that's for right triangles. Okay, that sine, cosine, tangent is for right triangles, okay? But if you don't have a right triangle, then you use the law of sines or the law of cosines, which I'll show you in a second. Yes?
Can we use the law of sines on right triangles?
You can. Good for you for asking that. Yes, you can, because you have a 90-degree angle, which can be a theta 1 or a theta 2. Yes. Yes, you can. Did you guys hear what she said? She said, can we use the law of sines on right triangles? Absolutely, because you have a 90-degree angle, which would be one of your, right? And the reason it works is because the sine of 90 is... Okay, so, now find the area. Now there's another formula for area. So if I take a look at this triangle, right, and I need the area, okay? So one way, and I'm not going to do it, but I'll hypothetically draw on the board. Okay, one way to find the area of this triangle, which you guys would probably do the long way, bring it down, make a right angle. You guys with me, right?
Yeah.
And we could probably use, for this, we could use the sine of 58 is equal to A over 5, right? And then to find the area, then you'd go the base, which is 1/2, the base, which is 6,
But it's not 1/2.
times this answer, right? Well, that'd be 5 sine of 58 equals A, right? Right, you with me?
Mr. Davies, A would not be divided by
1/2 base times height, right?
that. But
Let's call this H for height.
Mr. Davies,
It's not half a 6.
the bottom angles aren't the same, so you can't just divide them by.
No, I'm finding the area of this triangle. How do you find the area of this triangle?
The 6.
No, just a bit, a whole triangle. How do you find the area of the triangle?
Mr. Davies.
It's 1/2 base times its height. Is that the area of this triangle?
Not for this triangle, dog.
No, I want the whole triangle. I don't care about that whole triangle. I want
No,
the triangle.
no, it's like for the whole triangle.
I know, I want to find the whole triangle. What's
Oh
the
my
base of the
God.
triangle? 6. I don't care
Okay.
about this little triangle
Okay,
here.
I have a question.
Yes.
If I draw a line straight down that's at
It
like
doesn't cut in half.
3/8, yeah.
I
And
know.
you can't just divide by 2 because the area isn't. gonna-
What if I put this right here? Just for a second. What if I put that right there?
I am confused. You don't know what's going on.
Right?
When you just like do 5 times 6 and then divide that by
It makes sense to me.
I'm just scared.
Okay, real quick. Here's what's bothering you. Okay, real quick. Forget about everything. Let me just erase all this mess for a second.
And then the sign, whatever, that's all.
Okay, now, forget about
Makes sense.
this triangle, the big triangle, In fact, you get it. You see it wrong, don't you? The big triangle. Okay, normally find the area of a triangle is 1/2 base. What's the base?
6.
Thank you. What's the height? We don't know, but we can find out what the height is, right?
5 sine 58.
We can find out the height from the little triangle, right? And then once we get the height, we plug it in. So the height really is 5 sine 58, right?
Yeah.
Yeah, so I'm really pretty much giving you the formula, because the formula is really 1/2 this side times this side times the sine of this angle. You don't have to do half that work at all. You don't have to draw this down at all. The formula really is, do you see where I'm going with this on this formula? Okay, I'm going to prove it on this one, okay?
No.
Yes, go ahead.
Okay. To write the equation, am I right to go 5 sine 58 all within the parentheses, or is it all supposed to be outside parentheses here? At the 5 sine 58.
Oh, mate, it won't be. It was 5 times. It won't
Okay.
be. It's good.
Just
All right,
wanna-
now, take a look. Let's do it this way, okay? All right, so what if I bring down and call this H for height? Okay, let's see if we can find the height. Okay, so if I want to find the height of this triangle, there's a right triangle, right? To find the H, I would go, okay, I could go technically sine of theta is equal to the opposite over this adjacent. We'll call it adjacent 1, okay? Okay, does that make sense?
Yes.
And then if I multiply it up, I'd say then the height is really equal to the adjacent 1 times the sine of theta. Okay, you with me? That will give me the height. Everybody agree with that?
Yes.
Always. Now, what's the area of a triangle? The area of a triangle is 1/2 its base times its height. Ooh, we're going to do a math proof here in just a moment. We haven't done a proof in a long time. We're actually going to prove the formula. Check it out. We're about ready to prove a formula, which is something you're going to do in college. If you take college math, you're going to do a lot of proofs. So here we go. Check it out. So then my area formula is this. Area is equal to 1/2 the base. Well, the base is this adjacent side.
We don't know what the base is.
We do here, 6. Times the height. What's the height? Well, the height is equal to the other adjacent side times the sine of theta. There is a new formula for area. Let's circle that. Let's circle that. So, area formula is 1/2 adjacent 1 times adjacent 2 times the sine of the angle. But it has to be what they call the inclusive angle. The inclusive angle is the one in between the two. Now, listen carefully. The inclusive angle, and I know the inclusive angle is this angle because it's included between the two sides. We know this angle here is not the inclusive angle. Hold on. This angle here is like it's out of it, okay? But adjacent, so what angle's in between? That's that angle. That's called the inclusive angle. Yes, Daisy.
So when you have to have an equilateral triangle,
Nope.
does it have to work?
Nope, always works. Because I proved it always works. Doesn't have to be equilateral at all. Always. Because by going this, I found the height. We know that the area triangle is 1/2 base, that's this side, times the height, right? Doesn't matter if it's equilateral at all, right? It's just 1/2 base times the height. And we found out that the height can be found by using the sine, right? So then we substitute adjacent sine of theta into the formula for the height, and you've got a formula that works for any triangle. It's right, equilateral, it doesn't matter. It works for any triangle. So my formula is just that. So check it out. Here's my answer. You ready? Area equals 1/2 6 times 5 times the sine of 58. That's my area. That's it. That's it. Now I did not use the 40, did I?
Mr. Davies, solve that and find a number.
I will put 5 times 6 times 5 times the sine. Oops, turn my calculator on. That helps a lot. Put 5 times 6 times 5 times the sine of 58. And I get an answer of 12.72
A realistic number.
centimeters squared. It's super easy formula. That is the formula. 1/2 adjacent 1 times adjacent 2 times the sine of your angle, and it has to be the inclusive angle. So theta is the inclusive angle. And inclusive means it's got to be the angle in between. I did not use the 40-degree angle, did I?
No.
You have to use the one that's in between the known sides. That's what inclusive means. And there it is. Boom. Done. So we found 2 new formulas today that made trigonometry even easier, didn't we? Right? We lost sines.
A different answer.
Stop.